Hello! For this experiment we're doing impulse and momentum. My first plan was to crash these two until I realized it was almost the exact same as the example video, and plus they don't crash very well together. So for this one we're going to be finding the force on my knees when I jump off a ledge and I bend them. I'll be doing the example later, but I'll start with the background first, and let's get started. I'm dressed up in my ninja attire because I'm gonna be doing ninja stuff. So I do like that. So we know F equals MA. I should write that bigger. And then we know A is the change in velocity over time. So you could substitute that in. And then we know mv is momentum p. So I'll write, in other words, it's change in pf minus change in p initial over change in time. And that's pretty much it. Impulse is just a change in momentum, which is also equal to F times change in time. So that's really useful for a lot of other applications, but we don't necessarily need it in this experiment. Let me preface this by saying don't do this at home, and if you do, bend your knees. Very important. That's it. Let's start with the experiment. Here's the ledge I'll be jumping off from. It's right next to my house. It's about 8 feet up, but I'll do the exact number when I get closer. And I'll be jumping off, and then we'll see everything I need. We'll check it later. Oh my god, this is a lot taller than I thought. Okay. I've done this before. I landed on the balls of my feet. In the video, you can see me contemplating whether to jump on the grass or on the concrete. The grass would have been a lot better, but I didn't have a good angle, so I just jumped straight on the concrete. So we'll be getting onto the calculations now. Right, so this is what we got originally, and this is what we know from the video, or at least not like analyzing it, is that the height I jumped was 8.2 feet. My final velocity when I stop moving, or I jump and my knees are bending and then I stop bending my knees, that's a final velocity of 0. And then I weigh 140 pounds or 63.5 kilograms. And then from the video, we do frame by frame analysis. And we could see that from the moment I hit the ground, that's me. So the moment I hit the ground, and then to the moment I fully stop, it took around 7 frames. And then my phone camera was recording at 24 frames per second. You get 0.292 seconds. Alright, remember that this time component is the moment I hit the ground, and then for that time it takes for my knees to actually stop me, or my velocity as I hit, and then I'm stopped to 0 velocity. So that's what that time is. Now to get that velocity just as I hit the ground, we're going to use our free fall equation. And so it's going to be this equation right here, so we don't have a time it takes for me to jump off and to hit the ground. So it's going to be this one. The velocity just as I jump off is going to be 0, and then gravity is going to be pull me down 9.81, and then 2.5 meters is the height. Solve for v, you get plus or minus 7 meters per second. And I'm going to assume y going up is positive, so that means I'm going downwards, so my velocity would be negative 7 meters per second. And then little demonstrations, my v initial right here is 0, My V initial just as I hit the ground is going to be negative 7 meters per second. My V final just right as I stop is going to be 0 again. And then we plug everything into this equation. Mass, 0 final velocities, negative 7 meters per second, which it becomes positive. And then the time it takes for me to hit the ground and stop is going to be 0.292. You plug that in, you get 1,522 newtons, or about 342 pounds of force on my body. Bend your knees, because if you don't bend your knees, the time component gets smaller and more force acts upon you.
Yeah.
That's recording.